So in this video, we're going to decompose a vector into two orthogonal vectors. So suppose that v and w are two non-zero vectors with the same initial point P. Okay? So I have the same initial point P. Right? We seek to decompose V. So V, we're going to turn it into vector 1, which is parallel to W, and V2, which is orthogonal to W. Okay? So say you have this point P and you've got your vector V coming out here. Okay, and you got your vector W going out here. Okay? So V1 is going to be parallel to W, right? So that's V1. And V2 is going to be orthogonal to W. Okay, so it's orthogonal to W. That's V2. All right? So, vector 1 here, this vector is the vector projection of V onto W. So what do I mean by that? Say pretend like we had this flashlight and we're shining down. Okay, we're shining a light down. So if we shined a light from above down, where would it project onto W? Well, that shadow would be created onto W right on this line right here. Okay, so that's the projection onto W. Okay, so that's the idea there. Okay, you're projecting onto W. Okay, so that makes a right angle. All right. So the vector V1 is obtained as follows. From the terminal point V, drop a perpendicular line down to W. Okay, that's what we've done there. Containing W. The vector 1 is the vector from the point P to the foot of the perpendicular. Now vector 2 is given by, how do we get vector 2? Vector 2 is given by V minus vector 1. Okay, you think about the negative of vector 1. The negative of vector 1 is going to go this way. So if I take that and I subtract it off, I'm going to get right there that V2. Okay? So V is equal to, if I add V1 to both sides, V is equal to V1 plus V2 as desired. Okay? So I wanted to write V as a component, as two different vectors added together. Okay? So now what we do is we seek a formula for V1 based on the knowledge that the vector V on W, since V equals V1 plus VW, so V dot W equals V1 plus V2 dot W, which equals V1 dot W plus V2 dot W. Now, since V2 is orthogonal to W, we know that this has got to be 0. Okay? And since V1 dot W, since those are parallel, okay, if the dot product is parallel, that tells us that V1 is equal to some constant times W, right? So this is going to be alpha times some W plus 0. So what does that tell me? Well, that tells me that V dot W equals alpha. Okay, so this V1 gets replaced with alpha W, and then I have the dot W right there. So that's alpha W dot W plus 0. Okay. Now this W dot W is equal to the magnitude squared by our formula that we developed earlier. And so to solve for alpha, I'm going to divide both sides by the magnitude squared. And that gets me alpha, okay? So V1 is equal to alpha W. Well, alpha is equal to V dot W over the magnitude squared, and then multiplied by W. Okay. So now we've created our formula. Here's your theorem. Okay. If V and W are two non-zero vectors, the vector projection of V onto W is V1 equals V dot W over the absolute value of W, the magnitude of W squared times W, okay? The decomposition of V into V1 and V2, where V1 is parallel to W and V2 is orthogonal to W, is V1 equals V dot W over the magnitude of W squared W, and V2 equals V minus V1. Okay, so let's use this theorem to find the solution of decomposition of two vectors. Okay, so I want to find the vector projection of V equals I plus 3j onto W equals I plus j. Okay, I want to decompose V into V1 and V2, where V1 is parallel to W, and V2 is orthogonal to W. Okay? Parallel versus orthogonal. All right. So how do I do this? Okay, so first thing I'm going to do is I'm going to graph. So V, I go over 1 and up 1, 2, 3. So this is my V. Okay. And then my over 1, up 1. That's my W. And so what I'm looking to do is I want to do V1 equals V dot W over the magnitude of W squared W. Okay, V dot W. So that's V dot W is equal to 1 times 1 plus 3 times 1. So that's 4 over the magnitude of W is square root of 1 squared plus 1 squared, which is square root of 2. So the square of the magnitude is the square of the square root of 2, which is 2. So this is times W. Okay? So that's 2 times I plus J, which is 2I plus 2J. Okay, so V1, I go over 2 up 2. So V1 is over 2 up 2. Looks like it's parallel. That's V1. Okay, so V1, 2I plus 2J. Okay. Now I need a V2. So V2 is going to do something like this. Okay, that's my V2. That's what I'm looking for now. How do I get V2? I do V2 is equal to V minus V1. So V, what was V? So that's equal to I plus 3J minus V1 is 2I plus 2J. So this equals I plus 3J minus 2I minus 2J. So that's minus I and then plus I. I'm sorry, plus J, rather. Okay, so this here is minus I plus J. Okay? So now I have decomposed my vector projection onto this. So V1 is equal to 2I plus 2J, and V2 is equal to minus I plus J. Okay? And that's all there is to it.